This is the Quantum Space Podcast, Innovating Trust. I'm Steve Atkins, publisher and editor of the Quantum Space, and tonight we're going to talk about ghosts. But not the kind that rattle chains or float down dark corridors. These are the ghosts that live in equations, haunt the gaps between measurements, and whisper through the laws of quantum physics. This is our Halloween special, Episode 10, The Ghost in the Machine. Every Halloween, we let the impossible feel possible. We tell stories about spirits and shadows, about things that are there one moment and gone the next. But physicists, they live in that world every day. Because quantum mechanics is a haunted house, full of things that appear, vanish, and reappear when you're not looking. Take the famous double-slit experiment. Fire individual electrons through two narrow slits, and they behave like waves, creating interference patterns. But the moment you try to observe which slit they pass through, everything changes. The wave pattern collapses, the electrons act like particles. It's as if the universe itself doesn't want to be caught in the act, like a ghost that disappears when the light comes on. What's more unsettling, that this isn't metaphor, it's measurement. Reality, it seems, only decides what it is when someone's watching. And that is spooky. Einstein called it spooky action at a distance. He was talking about quantum entanglement, the uncanny bond between two particles that once interacted. No matter how far apart they drift across a lab or a galaxy, a change to one instantly affects the other. Instantly. Not almost instantly, not really fast. Instantly. Faster than light. Einstein hated that idea, and Bohr simply shrugged and said, "It works." Today, entanglement is no longer an argument. It's the foundation of quantum communication, quantum cryptography, and teleportation, but it still feels haunted. It's as if the universe has invisible threads tying everything together, a spectral web connecting photons, particles, and maybe even us. Not magic, just physics. That hasn't finished explaining itself yet. If you're listening to this right now, and I seriously hope you are, there are trillions of invisible particles passing through your body every second. They're called neutrinos, or, as some physicists like to say, ghost particles. They barely interact with matter, they don't stop for atoms, walls, or planets. They just drift through. Unseen, unfelt, almost untouchable. And yet they are real. Every so often a detector deep underground catches one. A brief spark, a single flash, like a ghost caught on camera. And then there's dark matter, the invisible scaffolding of the cosmos. We know it's there because galaxies behave as if something enormous and unseen is holding them together. Physics may not believe in ghosts, but the universe certainly behaves as if it's haunted. Now, here's where it gets darker. The many worlds interpretation of quantum mechanics say that every possible outcome of every event actually happens. In one branch, you turned left. In another, you turned right. In one, you lived. In another, you didn't. And that brings us to a truly chilling idea: quantum immortality. If consciousness can only observe outcomes in which it survives, then from our own perspective, you might never die. You could be doomed to experience only those timelines where you somehow improbably keep going. It's not exactly comforting. Imagine existing forever, not as a soul, but as an endless survivor of infinite versions of yourself. A multiverse of the damned. Physicists and ghost hunters aren't so different when you think about it. Both sit in dark rooms waiting for the unseen to make itself known. Both argue about whether their instruments are sensitive enough, and both get the same look in their eyes when something unexpected happens. In quantum labs, we use words like entanglement, observation, collapse, decoherence. They sound like something from a séance transcript. But that's the real work of science, to stare into the unknown and coax it into revealing itself. When we measure a particle and its wave function collapse, we are, in a sense, calling the spirit of probability into the room. We ask a question, and the universe answers one ghostly particle at a time. Stephen Hawking once wondered whether black holes destroy information forever. If they do, it breaks the laws of quantum mechanics. And if they don't, then somehow that information is preserved, encoded into the fabric of space-time itself. And that's the paradox. In the quantum world, nothing is ever truly lost. Energy changes form, matter transforms, but information, the pattern of it all, lingers. It's the ultimate haunting, not of souls, but of data. A universe that remembers everything, even after it's gone. Arthur C. Clarke said, "Any sufficiently advanced technology is indistinguishable from magic." Maybe the same goes for physics. Particles tunnel through solid walls. Empty space seethes with energy. Vertical particles appear and disappear in a quantum foam of existence. You don't need a séance or a crystal ball. The universe is already performing tricks we barely understand. And if that isn't spooky enough, remember that every experiment we've done so far only deepens the mystery. Physics doesn't explain away wonder, it creates it. And so, finally, the cat. Erwin Schrödinger's famous thought experiment. A cat, sealed in a box with a radioactive particle and a poison vial, is both alive and dead until someone opens the lid. A creature trapped in a state of uncertainty, neither here nor there, neither gone nor fully real. It's the perfect Halloween metaphor, because what is a ghost if not a thing caught between worlds? Perhaps the cat isn't dead, perhaps it's just moved, sideways, into another branch of reality, purring in superposition, 9 lives and counting. In the end, quantum mechanics doesn't prove the supernatural, but it reminds us that the universe is stranger than we imagine and more mysterious than we'd like to admit. The deeper we look, the more reality behaves like a riddle. Particles that vanish, forces that act as a distance, information that never dies. So this Halloween, when the lights flicker and the shadows seem to move, remember, physics already gave us all the ghosts we'll ever need, and they're everywhere. In the air, in your body, and in every cubit of existence. Because that line between science and the supernatural was always quantum thin. You've been listening to the Quantum Space Podcast, Innovating Trust. I'm Steve Atkins. Happy Halloween, and remember, don't open Schrödinger's box after midnight. This was Innovating Trust, a quantum space podcast edited and produced by Crown Communications.